discussion in earlier classes. So exclusively now we'll focus on this one. So now we know due to point charge, what is the electric field due to point charge. Already, once again, I discussed. So for your benefit, once again, I'm bringing. So at point P, what is the potential? KQ by R. And we know what is the electric field strength? KQ by R square. Shall we differentiate this? Let me differentiate, we'll see first. So let me differentiate. dV is equal to minus KQ by R square into dr. So dV by dr is equal to minus KQ by R square. So this will become dV by dr. Okay, KQ by R square, what you can write it as E. So dV by dr equal to minus E. So how the electric field and potential are related, given by this particular formula. Okay, agreed, no? So there's a one thing. So if you know potential, just take the derivative of that, you'll get the electric field. Similarly, I want another thing. So we know work done F into dr, work done by any force. So I'm interested now, work done by electrostatic force. Work done by electrostatic force should be equal to F into dr, that one. Now work done by electrostatic force, what we can write it as minus of delta U. Work done by electrostatic force in moving a charged particle from 1 to 2. And now further, what is F? You can write Q E bar dot dr bar. Delta U, what we can write? Q into potential difference. So this Q gets eliminated. So minus of delta V is equal to E bar dot dr bar. So this will be nothing but the potential difference it is. So now let me do one thing, limit 1 to V1 to V2, 1 to 2. So this will become minus of V2 plus V1 is equal to integral of E bar dot d bar, or V1 minus V2. Instead, a generalized formula, what we can put it? dV is equal to minus of E bar dot dr bar. Okay, this will be our generalized formula. So if you know potential, so V1, V2, this is 1, 2. Before simplifying, okay, this is a thing. So this is what I'll be using to find out the, if I know field strength, I can find out the potential. If I know the potential, I can get the field strength. There's a one generalized discussion. Similarly, okay, well, we have one more important thing, like work done in moving a charged particle from 1 to 2 by electric field, by external agent. How to calculate this one? Because these will be very exclusive. I'll be using that one. So according to this formula, work done by electrostatic force in moving a charged particle from 1 to 2 should be equal to delta U, change in potential, minus of delta U. Work done by conservative force should be equal to minus delta U. Okay, then after with this, what do you mean by delta U? U2 minus U1. What is this? Potential G should be equal to Q into potential difference, or potential charge into potential. So this charge you take outside. So this will become V2 minus V1, or this will become Q V1 minus V2. So work done by electrostatic force in moving a charged particle from 1 to 2 is equal to that particular charge into potential difference. How work done by electrostatic force and work done by the X-ray agent are related. So we know that there'll be always work done by X-ray agent in moving a charged particle should be equal to plus delta U. Because electrostatic force is a conservative force. Work done by conservative force should be equal to minus of change in potential. Work done by X-ray agent should be positive of change in potential. So from therefore, what we can write this as U2 minus U1. Then again solving. So how always work done by X-ray agent and work done by electrostatic force will be always equal and opposite. You can see from here. Note, let me write it separately. Work done by X-ray agent in moving a charge from 1 to 2 should be negative of work done by electrostatic force in moving a charge from 1 to 2. All this is the thing which will help us a lot in solving some set of numericals. So what is the basic idea? If you know potential, you can get the electric field. Okay, any doubts? If you have, you can clarify. I'll directly enter into the numericals part. This will be very widely, you'll be coming across this. You have to remember this condition. Yellow color, green color, what I highlighted, finally, this is what we are going to use in the numericals. A very generalized conclusion. So you can see, you can work out so many numericals just based on this idea. Okay, let me do one thing. Let me directly. So what is use of this studying? See, now more math-based problems are there, but in physics, what happened rather than that math-based, no, we'll be focusing more on numericals of this kind. Okay, let's take a point.